Good. So welcome to VetStim's actually first clinical chat on a topic where we really have translational medicine and we have a relationship truly between veterinary medicine and human medicine. And I have with me Tom Icahn, the CEO of MediStim, who has written really truly a landmark paper on rheumatoid arthritis, which is a disease we have in veterinary medicine as well as in human medicine. And thank you, Tom, for coming and having a chat and helping bridge a little bit veterinary medicine and human medicine. So tell us about this paper and why did you write this paper on rheumatoid arthritis?
Thank you, Bob. So, as you know, you've spearheaded for the past couple of years the use of the fat tissue in companion animals, in dogs and horses, to repair joints. And as you were doing this work, you also did some work in other types of diseases, such as rheumatoid arthritis, the dog version of it.
Right.
So that got us thinking. Our collaborators in Panama used the procedure, I've started using the procedure of using the patient's own fat stem cells for diseases such as rheumatoid arthritis. And the initial concept that got us excited, the initial outpatient observation, was that we started seeing in our patients similar responses as you were seeing in your patients.
Right.
So what got us thinking is, how do these cells work from a mechanistic point of view?
So we're truly doing from the bedside and the clinician's view of observations in patients, now back to the bench top and trying to get some science that supports why we see these clinical effects?
Exactly.
Okay.
Several years ago, we filed some data that we published that demonstrated there's a lot of immune regulatory cells in the fat. So the same fat preparations that are being used to treat whether it's dogs or humans, we identified that there is stem cells there, but also that there are regulatory cells that suppress diseases in which the body is attacking itself.
So if I was a patient and I had rheumatoid arthritis, or I was an MD instead of a DVM, and I had a patient with rheumatoid arthritis, we probably don't know what triggered it, but something caused the body to attack itself. So now I've got swollen joints and a lot of pain, and I'm very ill. So how did you think the cells might actually impact a disease like that? What is the thought? Because it's not just the thought of a stem cell that makes some tissue, which is what we all thought originally. What's going on scientifically here?
So it's very, very interesting. In general, a lot of the patients with these autoimmune diseases, whether it's rheumatoid arthritis or type 1 diabetes or multiple sclerosis, they have a deficiency or an inability of these immune regulatory cells to function. Basically, it's like a balance. In the normal situation, you have the immune cells that attack pathogens, different bacteria and viruses, and you have these counter-immune cells, immune regulatory cells, that control these immune cells from attacking the body. In patients with autoimmune diseases, these cells, these control cells, the immune regulatory cells, there's not enough of them or they don't work properly. What we found is that there's a depot of these cells. A lot of these cells are stuck in the fat tissue, where by coincidence there's also a lot of stem cells. So we figured that by using the cells from the fat tissue and putting them back in the body, you can bring the balance back, and at the same time you have stem cells that repair the damage that has been done.
Excellent. So using the patient's own cells and just taking them out, concentrating them, getting them sort of separated, but still it's a mix of cells. It's not a pure stem cell. It's this mix of cells, and you put them back in through an IV? Is that how you would administer them?
Exactly. It's a very simple procedure. You do a mini liposuction, you purify the cells in the certified laboratory, and then you put them back intravenously. And so far, we have treated a couple hundred patients with this procedure, and some of the data has been published already. Multiple sclerosis, which we published together previously, and now rheumatoid arthritis, which we've published.
Well, to me it's so fascinating and so fabulous because now we're truly linking up the clinician seeing things in the clinic, ability to use a patient's own innate ability to heal themselves, and we're just sort of helping it, and then now trying to apply the science to understand it. So now we've got from bench back to the bedside, or in our case, next to the stall, or next to the cage, and then coming back to the bench and trying to understand so we can optimize this. Because patients are variable, and we see that, but it's really spectacular to see, and for me as a veterinarian, to see clinical effects in many, many animals, and then to see that my colleagues on the human side are doing this, and we get the same set of effects in diseases where we really don't have good treatments. Somebody with rheumatoid arthritis or MS is facing a pretty tough road. And to be able to use their own cells with very limited side effects, it's hugely exciting. And I'm hoping that the name of one of the journals that you publish in is Translational Medicine, and that truly means taking it from the science concept and translating it to the clinic.
Yeah.
You guys are actually doing it, and that's exciting, and we're glad to share whatever we find in the animals, and we really appreciate the collegial effect of working back and forth and trying to figure out how we solve the disease problems. So
Thank you very much.
it's been an excellent time. I really appreciate it. I look forward to more discussions.
Absolutely. Thank you.
Thanks a lot.